Welcome to the video for the lesson 3-4 in the pathways to math literacy to algebraic, pathways to math literacy. This is lesson 3-4. You'll notice it says working with inequalities. That's really what we're going to be doing. That's one of the prep skills, inequality notation. We'll talk more about that as we go along. But anyway, check the prep skills. There's a lot of things you really want to know about greater than, less than. We call this symbol greater than. What it means is that the quantity on the left is greater than the quantity on the right. In school, sometimes people talk about an alligator. They think this looks like an alligator's mouth, and the alligator is hungry, so it's going to eat the bigger number. Sometimes people say it's a baby bird. But the point is, the big side of the symbol always goes to the big number. So this one we call greater than because 3 plus 5 is greater than 7. This one we call less than because 7 is less than 3 plus 5. At any rate, make sure you do the prep skills before you start the video. Read through the introduction to the lesson. Obviously, all quantities are not created equal. We're talking about inequalities. So we're looking at the snow cone lesson from the snow cone business from lesson 3-2. We're going to use inequalities to work with that. Lesson 3-3, we were solving equations. We're actually going to be solving inequalities in this lesson. So to do question 1, when you're done, restart the video. Okay, name a number that makes x greater than 3, 2. True. 2 would not work because 2 would not be greater than 3. But I can say x equals 4, in which case 4 would be greater than 3. That's true. Okay. And we can go on to question 2. Hopefully you will realize, as I've just said, x equals 2. That would mean we would have 2 is greater than 3, which is not true. So we're going to be working a lot in this lesson with whether or not an inequality is true, something we want to think about. Okay. Go on to question 3. Before you do that, though, these are the tools we use to solve equations. Okay. Basically, we did the same thing to either side of the equation, whether we multiplied, divided, added, or subtracted. We're going to do an investigation today to see if we can do the same thing with inequalities. So actually, for the classwork, go ahead and do 1 through 4, and then come back to the video, and we will discuss it all at once. Okay. The instructions are add 8 to both sides. 10 plus 8 is 18. 20 plus 8 is 28. Is it still true that 18 is less than 28? Is the baby bird still going to eat the number on the right? Yes. Okay. Number 2, add negative 8 to both sides. Adding negative 8 is like subtracting. So 10 plus negative 8 equals 10 minus 8 equals 2. 20 plus negative 8 equals 12. And if we look at that, yes, 2 is still less than 12. So we are doing the same thing to both sides of the inequality, and so far it's working out. Um, we're still able to do what we did with equations and still have our inequalities be true. Uh, Subtract 6 from both sides. 10 minus 6 is 4. 20 minus 6 is 14. 4 is still less than 14. And adding negative 6, or I'm sorry, subtracting negative 6 from both sides. Um, Negative 6, if we subtract a negative 6, that means what would the number have been before we added negative 6? That would have been 16. 16 plus negative 6 gives me 10. So if I have 10 and I take away that negative 6, I get back to 16. So 10 minus a negative 6 is like 10 plus 6. And likewise for 20, we get 26. 16 is still less than 26. So far, we're able to add the same thing to both sides or subtract the same thing from both sides, and we still end up with a true statement. Okay? So either does or does not is what you have to put in the blank here, and then use your number line to graph the solution. So once you've done that, restart the video. Adding or subtracting the same number on both sides of an inequality does not change the direction of the comparison symbol. When they say comparison symbol, they're talking about the less than or the greater than. And obviously we'll also be working with less than or equal to, greater than or equal to. Use the inequality tool to solve each inequality, then graph the solution on the number line. So they're wanting you now to do what we did with the equations. When we have x minus 5, we're going to add 5 to both sides. We draw the line to show that we're adding vertically. X minus 5 plus 5 just gives me x. 9 plus 5 gives me 14. And I will keep my greater than sign, so I know x has to be greater than 14. If I check it, if I put in 14, 14 minus 5 gives me 9. That's not greater than 9. But if I put in 15, 15 minus 5 gives me 10, which is greater than 9. So if I graph my solution on a number line, I usually want to put the 0 just to show where the 0 is. And all I really need to put is my 14. And I'm going to draw a squiggly line. We make the line fatter to show where the numbers that will work. So any number to the right of 14, which would be 15, 16, 17, and so on, will work. We want to show that 14 will not work. So I'm going to circle 14 to show that's where we start. But I'll leave the circle open to show that we don't want to include 14. 14.01 would work, but 14 itself will not. Negative 11, we subtract 11 from both sides. Plus 11 minus 11, I just have t. And less than or equal to 5 minus 11 is like 11 minus 5, which would give me 6. But since the 11 is bigger, I know I end up on the negative side. So I need to have t less than or equal to negative 6. And on my number line, I show show my 0. I'm also going to show my negative 6. If you want to put in some of the intermediate values, that's fine. But the main thing is to show the negative 6. And I now want to be less than or equal to. So I draw a fat line on the left side of my inequality. And now I draw a circle around my 6. to show that's the dividing line, but to show that we're going to include the -6, the -6 will work because now it says I can be equal to that. -6 plus 11 equals 5, and that's okay because I have the or equal line at the bottom. Okay. Go on to question 6. Restart the video when you're done. Question 6, write a verbal description of what the solution sets to the two inequalities in the colored box really tell us. The first has been done as an example. So they're telling us right away that for the first one, any value of x greater than 14 will cause x minus 5 to be greater than 9. And you have to do the same thing for the second one. And you can really say any number less than -6 will cause t plus 11 to be less than or equal to 5. There's a did you get it? If you don't get it and you don't see why, post a question on the message board. Go ahead and do 7 through 10. We're taking the same approach here, except we're investigating what happens when we multiply or divide. What happens to the less than or equal to or greater than or less than or greater than or equal to sign? What happens to that sign or the comparison symbol when we multiply or divide both sides? Restart the video when you're done. Okay, multiply both sides by 2, 20, 40. If I look at that, is 20 still less than 40? Yes, it is. And we start with 10 less than 20. Multiply both sides by -2. Negative times a positive gives me a negative, so I get -20 here, and I get -40 here. And if I look at a number line, and I look at my -20 and -40, -40 is to the left of -20. And we've talked before about negative numbers. When we talk about negative numbers, it's better to owe somebody $20 than to owe somebody $40. So -20 is actually greater than -40. Okay. Try the same thing with division. Divide both sides by 2. Divide both sides by 5. So we have 2 and 4. Is 2 still less than 4? Yes, even though I divided by 5, the left side is still less than the right side. If I do that with -5, once again, positive divided by negative gives me a -2. And 20 divided by -5 gives me a -4. And if I think about it, if I owe somebody $2 and I find $5, I can pay them back and have $3. If I owe somebody $4 and I find $5, I only get $1. So -2 is actually greater than -4. So I use the greater than sign. The baby bird would rather eat -2 than -4. Don't really want to think about how that plays out in terms of negative numbers. But anyway, hopefully you see what's going on. Question 11 is actually going to ask you to think about writing a rule based on what we just saw. So restart the video once you've done that. Okay, so stays the same or changes. So we look at the inequality solving tool number 2. So if you multiply or divide both sides of an inequality by a positive number, the direction does not change. But if you multiply or divide by a negative number, we found the direction does change. So we're going to use that now to solve these inequalities. So divide both sides by 2 to get x by itself. We have x is less than 5. We go back in and check. First thing less than 5 is 4. 2 times 4 is 8. That is less than 10. So if we graph it, we put our 0 and we put our 5. And we say 5 is the breaking point. We draw our fat line to the left, indicating all the numbers to the left work. We're going to leave our circle open because 5 won't work. It's just the dividing line. 4.999999999 will work, but 5 will not. If we come over here, same thing. We divide both sides by -3. We end up with z and 4. What we found, though, was we had to flip our inequality around. So now z actually has to be less than or equal to -4. So if I draw my solution line, -4, z has to be less than or equal to, so 4 is the dividing line. We go to the left, and it can be -4, so we'll fill that in. And then if we check, we go back in, z has to be less than -4. What's a number less than -4? Well, -5. -3 times -5, is that greater than or equal to 12? Well, negative times a negative is a positive. Positive 15 is in fact greater than 12. So it meets the greater than or equal to criteria. Same thing now. Hopefully you did this. If not, start the video when you're done. Now we're going to try multiplication. So I will multiply both sides by 4. 4 times 1/4, we add up 4 1/4, we get 1. 1 times t is t, and we are multiplying by a positive, so we're not going to change the sign. 4 times -3 is -12. So if I graph that, 0, -12, t has to be greater than -12. So I go fat on the right to show that the numbers to the right of -12 work. And I leave the circle open because -12 is the dividing line. -12 will not work. -11.999 will work. But I don't want to try that. I'm just going to try 1/4 times -8. I could have tried -11, but hopefully you'll see in a moment why I didn't. -8 is greater than -12, so it meets our criteria, and we want to know, is that greater than -3? Well, 1/4 times -8 is -2, and yes, -2 is greater than -3. Over on the other side, well, we have to multiply both sides by -3. Negative times a negative is a positive. 3 times a third is 1. 1 times b is b. And negative 3 times positive 2 gives us negative 6. But since we multiplied by a negative, we have to change our sign. Instead of less than or equal to, we say greater than or equal to. And then for our graph, we have our 0, and we have our negative 6. And we want to say greater than negative 6. So we make the fat line to the right, including all the numbers that are greater than negative 6. We want to say it could be equal to negative 6. So we fill in the dot. And if we check it, well, what's a number greater than negative 6? Try negative 5, but I'm going to try negative 3. Negative 3 is greater than negative 6. So let's try that. Negative 1 third times negative 3. Is that less than or equal to 2? Well, negative times a negative is a positive. 1/3 times 3 is 1. 1 is in fact less than or equal to 2. Looks like but did you get it? If you don't get it and you can't figure out why, post a message on the message board and we'll see what we can do. So, summarizing the steps for solving linear inequalities: simplify both sides of the equation, the inequality, if necessary, by multiplying out any parentheses, combining any like terms. Use tool number 1 to rearrange the inequality so that the term containing the variable is isolated on one side. Use tool number 2. Tool number 1, of course, was adding or subtracting from both sides. Tool number 2 is multiplying or dividing. So you multiply or divide to make sure that you change the direction of the inequality if you multiply or divide by a negative number. That's the only difference between solving inequalities and solving equations. Okay. So now actually there's another did you get it? So try that one. And if you can't figure it out, send me an email or go to the message board. Okay. So if we go on to our group work, question 1 in the group work, once you've answered that, restart the video and we'll discuss it. Okay, question 1. Let's get back to our snow cone business. So we've got our profit equals negative 245 plus 0.63x. Question 1, write an inequality that states in symbols that the profit for this business will be at least $100. Restart the video once you've done that. So we want the profit to be at least $100. So P has to be greater than or equal to. One of the confusing things about the terminology, when you have at least, that means the lowest number it can be is 100. It can be greater than 100. So P has to be greater than or equal to $100. And so if we go to our inequality, we go back up to our equation. So we'll have $100 for P, and we want our profit, which is negative 245 plus 0.63x. When we do that math, when we solve that expression, when we evaluate that expression, we want the answer to be greater than or equal to 100. So we want our profit to be greater than 100, but we want 100 to be less than our profit. Okay. Question 2 says solve this inequality. Come back when you have done that. Okay. So solving the inequality, first thing we do is add and subtract as needed to both sides. We get 345 is less than or equal to 0.63 times the number of snow cones. And if we think about it, to answer the question of that's stated, we need to make $245 and then another $100 to make the profit. So we need to make a total of, we need to bring in a total of $345. And now, to figure out how many snow cones that is, we have to divide by 0.63, because we get 0.63 every time we sell a snow cone. We need to see how many 0.63s there are in 345. And the calculator is telling me there are 548 0.63s. So we divide both sides by 0.63. And I have to be careful now. I don't always round according to the rules. If I look at the number I actually got, 547, 547.619 would give me exactly $100, but I can't sell that many snow cones. If I want more than 100, I have to have more than 547. So even if this were 547.2, I would still go up. I would still go to 548. So I need 548 snow cones. And a lot of times people like to rewrite this, and I do too. We get used to putting the x on the right when we write the original equation, but we get used to putting it on the left when we write our answer. So we want x to be greater than or equal to 548. And you'll notice I changed the sign as well, because instead of saying I want 548 to be less than x, I'm now saying I want x to be greater than 548. Those are really the same thing. If x is less than 548, if x is greater than 548, then 548 has to be less than x. So that's really a third way that the inequality can change. Right? Graph the solution on the number line. I've got 0, 548, and I go to the right because I want to include the numbers that are bigger than 548. And we know 548 will work, so we can fill in the dot. Go on to question 4 and restart the video when you're done. So question 4, show that one value from the solution set checks. So 548, I'm going to try 550 just for a round number. So let's say we assume we sell 550 snow cones. We're going to multiply that by 0.63. And we're going to add negative 245. And That's going to give us the profit. And you'll notice I'm using an inequality here because we're checking to see what we're doing. So I go back to my calculator, 550 times 0.63 plus 245, and I will push the negative button, and then I push the equals. I get $101.50. So then I can say P equals $101.50. So therefore P is greater than 100. Restart the video once you've answered question 5. Okay, question 5. What does the solution to the inequality tell us about the company? Well, profit is greater than 100. Basically, that's what it tells us. If you want the profit to be greater than 100, then you have to sell more than 548 snow cones. Restart the video once you've done question 6. Question 6, write a verbal description of what this inequality represents in the context of the snow cone business. So this inequality here, we're saying negative 245 plus 0.63 is less than 0. That negative 245 plus 0.63x actually represents profit. So this is saying that the profit is less than 0, or the business is losing money. Question 7 says solve this inequality. Restart the video once you have solved this inequality. We should end up with a number that we've seen before. And I'm not flipping the sign since we're not dividing or multiplying by negative. So I have 245 divided by 0.63. Maybe we didn't have that before. Any rate, 389. And actually, this kind of represents what I was saying. I should round off to 389, but at 389, it's actually 388.88888. So if I'm less than 388.888, then I will not make a profit. And actually, I do want to put the 389, because the first number of snow cones where I lose money is 388. I am slightly below making a profit at 388. So if I go to my number line, graph the solution on the number line, I have 0 here, 388 here. I'll put my circle around 380, I'm sorry, I'm still saying 388. It's 389. So I circle 389 because that's my breaking point. But I do not fill it in because 389 won't work. And then I make a fat line all the way to the left for all the numbers that are less than 389. And you could argue that you really don't need to make the line below 0, because you can't sell negative snow cones. Doesn't make a lot of difference. Restart the video once you've done question 9. So I'm going to do one value that from the solution set. I need a value less than 389, and I will use 388. And I will calculate P. And if I go to my calculator, so 388 times 0.63 plus 245 negative, and I say equals negative 0.56. So P equals negative $0.56, which demonstrates that P is less than 0. What exactly does the solution to the inequality tell us about the business? Restart your video once you've answered that. It tells us that the business just barely breaks even at 389, and it's just barely in the red at 388, or it's losing money if it sells 388 snow cones. Looks like we've got a did you get it? If you don't get that and you can't figure out why, go to the message board or send me an email. Question 11. Restart the video once you've done question 11. Okay, the temperature inside a room housing computer servers is important to proper function. A Google search for server room temperature yields the following, among other results. According to OpenExtra, server room temperature should not dip below 50 degrees Fahrenheit and should not exceed 82 degrees Fahrenheit. The optimal temperature range is between 68 and 71 degrees Fahrenheit. So write an inequality to express the statement, server room temperatures should not dip below 50 degrees Fahrenheit, mathematically using the letter F to represent temperature. So we want temperature, or F, not dip below, so not be less than. Not less than is the same as greater than. So 50 degrees Fahrenheit. And it's probably not a good idea to use F for the temperature, because to say degrees Fahrenheit, I need to say degrees F. So this is really just my units. This is a variable. Restart the video once you've done question 12. In lesson 2-4, we learned that Fahrenheit and Celsius temperatures are related by the equation F equals 9 over 5 times C plus 32. Use this to turn your inequality from question 11 into an inequality with variable C. So C now is going to represent the degrees Celsius. And so I'm going to take this expression, which is equal to F, and I'm going to plug it in for F. So now I want 9/5 C plus 32 to be greater than 50 degrees Fahrenheit. Restart the video once you've answered question 13. So question 13, we want to solve this. First thing we do is add or subtract as we need. We need to subtract the 32. 18. We subtract 32 from both sides, and now we have 9/5 c is greater than 18. I'm going to multiply both sides by 5 and divide both sides by 9. But I can do that all at once in one step. So the 5s and the 9s cancel each other on the left, and I have c is greater than 18 divided by 9 is 2. 2 times 2 is 5. 2 times 5 is 10. So I know that C has to be greater than 10 degrees Celsius. Try number 14. Restart the video when you have finished that. Should not exceed 82 degrees Fahrenheit mathematically. So we're going to say F. And should not exceed means it can't go over. So it actually, we want F to be less than 82 degrees Fahrenheit. And I want to get a little technical here. It says should not exceed 82, which means it can be 82. And it reminds me I got to go back. So should not dip below. It has to be greater than or equal to 50 degrees Fahrenheit. Should have done that here too. Didn't think about that. But it is important to look at the words. So should not exceed 82. It has to be less than 82, or it can be 82. Okay. And question 15 wants you to do the same conversion to change that into Celsius. Once you've done that, restart the video. So we want F, which is the same as 9/5 C plus 32, to be less than or equal to 82. Question 16 wants you to solve that. So go ahead and do that, and then restart the video when you're done. So when we solve it, the first thing we have to do is add or subtract so that we get the 9/5 C by itself. So then are equal to 82. Once again, multiply by 5 over 9. And as you can see, I'm not paying too close attention. Okay. 82 minus 32 is 50. Multiply both sides. Multiplying 5/9 times 9/5 gives us 1, which is 1 times C gives us C. So C has to be less than or equal to, let's use the calculator for this one. So 50 times 5 divided by 9, 27.777. So if I go back here, C has to be less than or equal to 27.7. If I say it could be equal to 28, 28 would be what I would round it to. So if I say it has to be less than or equal to 28, if it were 28, it would actually be above 82 degrees Fahrenheit. So it'd be less than a degree Celsius above. It'd be 3/10 of a degree above, but it would be above. So even though 27.777 is closer to 28, I want to say C has to be less than 27. Try number 17 and restart the video when you're done. So 17, they want us to write a single inequality. This may have been confusing for a lot of people. To do that, we've got two things that we've done. So question 13, C has to be greater than or equal to 10 degrees Celsius. I'm going to rewrite that. I'm going to say 10 degrees Celsius. And just for clarity, I'm going to get rid of the degree symbol. So C has to be greater than or equal to 10. 10 has to be less than or equal to C. And we just decided C has to be less than or equal to 27. So we're going to write that all in one line. So 10 has to be less than or equal to C, which then has to be less than or equal to 27. Question 18. Restart the video once you've done that. Okay, so the degrees Fahrenheit, if we go back, so we're 50 and 82. So we can just write it that way. So 50 is the lowest. F has to be somewhere in the middle. 82 is the highest. So F has to be less than or equal to 82. F has to be greater than 50, which means 50 has to be less than or equal to F. Try 19 and restart the video when you're done. Use the conversion formula to rewrite your compound inequality in question 18 with variable C. Then solve this inequality to determine the optimal server temperatures in degrees Celsius. Does this match your answer to question 17? They make a note to do a compound inequality. You have to do the same steps to all three parts of it. I don't know why they say sides, but I would say parts. So we're going to start with our 50 less than or equal to, instead of F, I'm going to put 9/5 C plus 32, which has to be less than or equal to 82. To get C by itself, the first thing I have to do is subtract the 32. But if I do that, I have to subtract it from this side of the inequality. So I've got two inequalities working here in one thing. I'm also going to have to subtract it from this side of the right inequality. So I end up with 18 less than or equal to 9/5 C, which is less than or equal to 50. Now I multiply everything by 5/9. It's hard to squeeze everything in. And 5/9 times 18 again gives me 10, which has to be less than or equal to 5/9 times 9/5 gives me 1. 1c is just c, which then has to be less than or equal to 27. Looks like we are done for this lesson. So onto your portfolio. Once again, online practice refers to the ALEX. You need to do your ALEX and then complete the applications and submit them to the website, to D2L. Thank you for watching, and I will see you for actually the next thing we're going to have is review for our test. Our test is coming up. So I will be communicating with you about the review for the test.